For every request, it doesn't go back to the origin. Instead, it is cached and subsequent requests are delivered via the point of presence. And that is called the content delivery network. It complements object storage to deliver low latency, immersive experiences to end users. If you're accessing media streams, photos, and a variety of static content, in all probabilities, you would be talking to a CDN rather than an object storage directly. That is very transparent to the end user, of course, but the CDN is what is making object storage more performant and more accessible. Then there is block storage, which is the next step in the evolution of public cloud storage. And this closely simulates the direct attached storage for traditional servers. So in direct attached storage, you unplug and plug a variety of SCSI disks or magnetic disks to an existing server, and that will dynamically increase the storage capacity of your server. Similarly, when a VM is launched in the cloud, you can attach multiple block storage devices which will be instantly visible to the server, and you can dynamically expand the capacity of your intrinsic storage delivered via block storage. This is a very, very important storage building block for running performance intensive and IOPS intensive workloads like databases or ERPs like SAP or any transactional workloads that require low latency read-write throughput. The third one is file storage, and you can think of it as NAS available on the cloud. So if you have your existing applications that are highly dependent on the SMB file systems or NFS file systems coming from Windows background or Linux background, they need to have exactly the same mechanism to continue to work in the cloud. And many legacy applications and traditional applications heavily depend on file systems and file shares to function correctly. So to enable that, cloud providers like IBM have exposed file storage in the cloud, which means if there is a UNC path that your application is expecting for the data to become available, you can mount exactly the same UNC path in your applications and they'll continue to work as is. So this is enabling the lift and shift scenario of applications from on-prem to the cloud, and file storage is one of the biggest enabler of that. Then there is cold storage, which is much cheaper. It is available at a fraction of any other storage choices we have discussed so far. And this is meant for replacing the tape backups. Obviously, when you're storing data, you have multiple categories or classes of data. Some needs to be accessed very often. Some is maintained only for retention purposes, and it is accessed on demand. So whatever you would store in tape cartridges and archival storage mechanisms would obviously go into cold storage. They're not instantly accessible, but you can request and you can retrieve the data over a period of time. That's the reason why it is called cold storage. More on this later. But essentially, looking at the available choices, it is object storage, which is almost like file system, meant to store static content of any type. Any MIME type can be stored on object storage. Block storage is emulating magnetic and SSDs in the cloud. You can very quickly plug in a block storage and increase the capacity of your VM storage. File storage is exposing NFS-like storage in the cloud. Cold storage is a straight alternative to your tape backup. So that is the landscape. Now, taking a closer look at object storage, which is the theme of today's webinar, let me talk about the scenarios. What are the customers using it for? What can you do with public cloud storage, particularly object storage? Well, the first thing is data lake. And again, this is a very critical use case. We are going to spend a significant amount of time articulating what customers are doing and why this is becoming the trending scenario for enterprises. Then I'll talk about backup and recovery. This is another important use case, which is very quickly replacing traditional archival mechanisms. Then we talk about an emerging scenario, which is cloud native storage, all based on containers and microservices. Then we talk about object storage acting as a centralized file server, particularly in branch office scenarios. I'm going to spend some time walking you through the architecture and how customers are benefiting from it. And finally, we talk about compliant data repository and touch upon use cases from the healthcare and financial industries. So this is the significant use cases that we are list of use cases that we are seeing in enterprise. At this point, I want to bring up a quick poll and ask you on what is the top use case that you are using cloud storage for. You got a few seconds to participate. We appreciate you taking time and telling us what is your priority use case for cloud storage. All right. It's not very surprising to see backup and recovery topping the usage, because that is what most of the customers are using cloud storage for. So 55% of you voted for backup and recovery as the most important use case, followed by centralized file server, and then the cloud native storage, which is very interesting, data lake, followed by compliant data repository. So this is in line with what we are seeing in the market and what we are actually experiencing with large enterprises. So on that note, let me walk you through some of these use cases in detail. The very first one, which is data lake. The reason why data lake didn't get the top slot in the poll is because it's one of the emerging use cases. And a data lake in itself is a use case that is evolving, which is highly based on the big data and analytics scenario. So I'm not surprised that it is not the top use case, but we are very sure in about a year or so, this is going to be the topmost scenario for public cloud storage. So what exactly is data lake? Well, Internet of Things is fundamentally changing the way businesses are done. Many sensors, many devices, and when I say devices, I mean CC cameras and various devices like even mics, a variety of sensors that are generating data. So for a long time, this data was never captured. And for the last 1.5 to 2 years, businesses realized the value of capturing the data generated by these sensors and devices. And they started to stream that into a variety of formats, for example, time series, unstructured, NoSQL, and so on, and started to analyze it with a variety of front ends. But as we see the explosion of devices and the uptick for IoT, what we are also seeing is the ability to retrieve native data, for example, video streams coming out of CC cameras and image frames, image grabs that are coming from a variety of surveillance cameras. And in some cases, even the conversations that the contact center agents have with their customers, raw images captured from healthcare systems. So they are not typical time series data where you have a timestamp followed by a number. These are very, very rich, very insightful data sets that need to be stored in their raw form, in their native proprietary format. And for that, you need petabytes of storage, which is going to mix and match data coming from a variety of systems. So data lake is essentially a storage engine, a repository that is capable of maintaining data in its raw format. So this is going to be the foundation for a lot of analytic systems, because many front ends and many data processing pipeline applications will rely on the data lake to start processing the data. For example, the sensor data will be correlated with the CC camera feeds, and you will be able to see very immersive experiences and very immersive insights. So the data lake is a very, very important aspect of the future machine learning and AI applications, because they are going to make sense out of the raw data. And in fact, Prachush will cover quite a bit of technical details related to data lake, but this is one of the top use case where enterprises will start leveraging the cloud-based object storage. Now, coming to the next one, the offsite backup. If you are in the business of dealing with data, and typically every business is dealing with data, and data is becoming so critical that you need to treat it almost on par with compute and any other system. And traditionally, the backup was always done to an offsite or a remote data center. So when you actually call a business continuity expert and show him your existing backup strategy, the very first thing that he would recommend is doing a remote backup and reducing the mean time between failure. So mean time between failure, or MTBF as they call it, is the ability for you to roll back in case of a disaster and get back to a point just before the disaster occurred. Now, depending on the strategy that you opt for, your MTBF windows will vary. Object storage is one of the best remote data centers or remote sites for you to start backing up critical data. And depending on how you actually leverage it, based on a variety of classes of storage, you can reduce the mean time between failure. You can also define retention windows. For example, your quarterly sales records and spreadsheets, they need to be accessed more often during the fiscal year. So you might want to classify that as the warm data or hot data and keep it in a more accessible, more readily available bucket. And for example, customer records that are only retained for the purpose of compliance and regulation, you can move that into a cheaper tier, which is not instantly available, but can be accessed on demand. That is what is called as a cold backup. So you can define those retention strategies and storage classes to reduce the cost, and also adjust accordingly based on your MTBF windows. So this is one of the other use cases where customers are relying on cloud storage. And this is very quickly replacing the traditional tape cartridges and even the more recent DVD-based backup systems. The third one is my favorite, which is cloud storage for cloud-native applications. What exactly is cloud-native? Well, let me spend exactly 30 seconds defining what is cloud-native. Cloud is basically of two layers. The first one is the infrastructure, which is very elastic, very flexible, very dynamic, and much cheaper than your traditional hardware. While infrastructure has become elastic, dynamic, and cheaper, the second layer, the applications layer, hasn't been able to take advantage of the underlying infrastructure and its elasticity. So cloud-native apps are the modern, contemporary breed of applications that are exclusively designed to take advantage of the underlying cloud infrastructure. So when both the infrastructure is cloud-native and the applications are also cloud-native, you get a terrific advantage of scaling. So unfortunately, applications that are written and deployed within VMs are not instantly cloud-native. They still use the legacy way of scaling and legacy way of exploiting the cloud capabilities. So cloud-native applications are written in a slightly more modular and composable form, and they are packaged and deployed using containers instead of VMs. So applications that are packaged in containers running on modern cloud infrastructure are called cloud-native applications. And these cloud-native applications are managed slightly different. For example, the orchestration managers and container management platforms like Kubernetes will manage the life cycle of these cloud-native applications. And one of the critical pillars, like any other application, is storage. So you need a slightly different modern storage engine to run your cloud-native applications. And guess what? The object storage, when expose it slightly differently to the cloud native applications can become the storage fabric even for cloud native apps. And the best thing is, if you are interoperating between your legacy applications running in virtual machines and contemporary applications running in containers, you can still rely on the same cloud storage fabric to share data between these two breed of applications. And increasingly, we are going to see the consumption of object storage from cloud native apps. For example, the IBM Cloud Container Service, which is based on Kubernetes, can natively talk to the IBM Cloud Storage Engine, and you can expose these storage capabilities to your containerized applications. And this is going to be a very exciting mechanism to manage the life cycle and scale the applications dynamically. So that is cloud storage for cloud native applications. And coming to cloud storage as a centralized file server, again, this is basically using the cloud storage as a file system, but in a different form. Imagine a scenario where you have a branch office deployment. So you have a headquarters in one location and multiple branches spanning multiple cities, and you want them to instantly share data. And data that hasn't been accessed for a long time will automatically move away from the local storage, maybe a SAN, thus freeing up the space, but still making the data available in a central location. So this opens up a new opportunity, which is called Enterprise File Share and Sync, EFSS. And the EFSS is becoming one of the biggest enabler for real-time collaboration. Though cloud object storage is the backbone, it is not instantly providing the sync capabilities. So to make this possible, there are third-party ISVs who are leveraging the object storage and opening up the file access, sharing and sync capabilities. For example, Citera is one of the EFSS provider on top of IBM Cloud Storage, and it instantly enables the ability to share and sync files. And it also opens up new avenues. For example, sharing your home directories when you're running VDI. So VDI is a virtual desktop where your actual workstation is running in a shared infrastructure. It could be public cloud, it could be your private cloud. One of the challenges with VDI is enabling your home directory or your profiles to move along with you. So by moving your home directory of your VDI desktop to cloud storage, you actually get a very seamless portability and very seamless roaming experience. You can log in from anywhere and your files will be instantly become available. And the magic behind that is handled by the file share and sync, which is powered by the underlying cloud storage. So this is a very exciting use case that is used by mid-market customers and small and medium customers who would want to reduce the cost of owning up hardware and reduce the total cost of ownership of running desktops on-prem. This is another scenario you might want to explore, particularly if you want to reduce the cost and have a very dynamic mechanism of running desktops in the cloud. And one of the last scenarios that I want to touch upon is cloud storage as a compliant data repository. It's not surprising to see sensitive industries that once were very skeptical of using public cloud storage aggressively moving to public cloud. For example, healthcare, it has been very skeptical to exploit cloud because they were worried about the privacy, the confidentiality, and the security of sensitive patient information. But today, many healthcare companies are moving raw data of patient records and the radiology records data to the public cloud. They are stored in its native form. For example, the X-ray images are stored in DICOM format natively in the public cloud storage, and they are instantly becoming available to a variety of doctors and insurance companies. And public cloud is becoming more and more compliant. For example, HIPAA is one of the standards that is used by healthcare companies and insurance providers to securely share the medical reports of a patient, and the insurance claims are based on the data that is being stored in the public cloud storage. The other example is how financial industries are making use of compliant data repository. There is a standard that is evolving, which is actually the SEC 17A4, which is a very recent regulatory compliant law that ensures that data is immutable. And what is immutable data? Well, in financial industry, the records need to be created once and read multiple times, and no one can modify the data. It sounds like blockchain, but it need not be as complex as a blockchain. It is essentially called as WOM, write once, read many, because the transactional data that is attached to a specific transaction got to be immutable. It cannot be edited, but it can be read by multiple parties. And the compliance that dictates this is what is called as the SEC 17A4. You can read more about it, but essentially this enforces a compliancy, which is basically making the data write once and read many by multiple parties. And IBM Cloud Storage is one of the few vendors to have this certification, which is encouraging many financial industries to adopt the public cloud storage to store warm data, which is write once, read many. So that basically summarizes some of the top use cases. And I want to talk about what's next for cloud storage. Well, I'm sure you would have heard about a new emerging compute service called serverless. And this is becoming a trend in IT departments because there is nothing to manage. It reduces the ops overhead, and you can essentially deal with code instead of spinning up VMs or containers. For example, IBM Cloud Functions, based on the open source Apache OpenWhisk, is an example of such serverless compute layer. And object storage is going to be integrated with serverless. Just like VMs and containers take advantage of object storage, serverless will be benefiting quite a bit from object storage. So every time a new image is uploaded, it will trigger a new serverless function, and you can immediately process it. For example, a high-res image being uploaded to a bucket will be immediately encoded into a thumbnail and gets delivered on a different form factor. That level of integration is possible through serverless computing. And multi-cloud synchronization is also becoming one of the important trends. So once you upload data to a specific cloud provider, because of the compatibility, S3, because it's one of the very early services, and there are many tools built in the ecosystem, that has almost become like the standard. And thanks to the S3 compatibility, even IBM Cloud is S3 API compatible, which means you can upload the data to IBM Cloud and seamlessly synchronize that with any other public cloud storage that supports the same API, and you can have multi-cloud synchronization. And this is going to deliver another level of availability because your data is now synchronized not just in multiple locations, but across multiple clouds. And then with edge computing becoming a reality, object storage endpoints will be exposed at the edge. And this will enable low latency ingestion from surveillance cameras, CCTVs, CC cameras, mics, and a variety of sensors that actually stream unstructured raw data. So this is going to enable AI inference right at the edge. So object storage will become an important pillar for artificial intelligence running very close to the data, and that will make object storage come to the edge. So these are some of the evolving scenarios. At this point, I would like to hand it over to Pratyush, who will walk you through the IBM perspective and IBM service offerings around public cloud storage. Pratyush, over to you.
All right. Thanks a lot, Johnny, for your view on the object storage. Good morning, good afternoon, everyone, depending on which region are you in. This is Pratyush Khare from IBM. I run the technical sales team for IBM Cloud Infrastructure as a Service. Before I start, I want to wish all of you a very happy new year. I know it's quite late, 10th day. Cloud brings endless possibilities. I'm a believer, and I think 2018 is going to be an exciting year for cloud. So coming back to the topic, what I'm going to be doing is 3 things in the next 15 minutes. Number one, I'm going to talk to you about what is IBM Cloud Object Storage, what is the market standing, which is the slide you're looking at right now, names of customers who are using it. That's number one. Number two, I'm going to talk about 2 use cases that Johnny touched upon in his session, which is data lake, backup, and recovery. How can you combine these 2 requirements and use IBM Cloud Object Storage, and how our customers are using it? In short, how do you protect your data lakes using object storage? And the third thing, which is the last section, is the favorite section, which is how much does it cost and how does it compare against Amazon Web Services? Through this, I will have 2 poll questions for you. It'll be interesting to have your feedback on those, just like you gave your feedback on the earlier poll question. So let's get cracking. On the right-hand side on this slide, you see 2016 IDC MarketScape report on object storage. IBM is right on top. IBM Cloud Object Storage, or ICOS in short, is something that you'll probably see a reference for. Just to give you a little bit of history, IBM in 2015 acquired a company called CleverSafe. If some of you probably may have heard of it. CleverSafe has been a leading object storage technology. IBM acquired that in 2015, and we renamed it as IBM Cloud Object Storage. And now we use CleverSafe technology to sell our object storage on IBM Cloud. Okay. On the left-hand side is 2017 Gartner Magic Quadrant, which is a combined Magic Quadrant for scale-out NAS and object storage. And you will see a reference of IBM in the top quadrant. So it is a leading technology from a technology perspective. It all comes from a CleverSafe acquisition. Moving on, these are the customers who are using it. And you'll probably see towards the end of the presentation a video of one of our customers who's using IBM Cloud Object Storage. It's a university in US, Chicago University, who is doing analysis of the patient records to do cancer-related research. Huge amount of analytics happening on the data stored on ICOS. So many of them, again, they cut across all kinds of use cases, but as it came up in poll, backup and recovery is the top use case among these customer names that you see here. So let's get into the use case that I want to spend some time on, which is going back to Johnny's session. He talked about a data lake use case. I'm going to combine that, which is if you have Hadoop running in your organization, whether it's running on-prem or running on cloud, how do you protect the data running on the HDFS? That has been a top question for many of our customers. And it's not that straightforward. So we will talk about what's tricky in protecting Hadoop infrastructure running data lake, and how can IBM help you in solving that.
No.
Hi, I'm hearing some background noise. Can you go on mute, please? Thank you. All right. So let's talk about Hadoop. Everybody has heard of Hadoop, right? I mean, in simple terms, Hadoop is used to cleanse, crunch, and analyze large sets of unstructured data. And I think it's becoming pervasive. If you go back to the poll that we did earlier in the session, 9% of you said you're going to be using object storage for data lake. 55% of you said you're going to be using it for backup and recovery. How about combining these two and talk about backup and recovery for data lake? Because that is a use case. Many of the large customers I worked with did not think of protecting the data lake, but that is indeed a requirement. So let's talk about that. Hadoop is great for what it's designed for, but I would say it's in early stages and efficiency is an issue. Let's talk about what those are. So most of you probably would be familiar when Hadoop by design would store 3 copies of the data on the Hadoop cluster, HDFS. You can change that, it's configurable, but most HDFS implementations I have seen would have 3 copies. Mind you, it is not for the resilience purpose. These 3 copies are not designed to protect data. They simply create 3 copies to be able to crunch the data more effectively. They distribute the 3 copies of data on different Hadoop nodes so that whichever Hadoop node is easily available and is less busy can crunch that data. So the purpose of having multiple copies in Hadoop is not for resilience. It is simply to make it more fast. So don't think that if you have 3 copies, well, if you lose 1 copy, you're going to have 2 copies. No. If you by mistake delete the one copy of that data, all 3 copies would be gone because they were not designed for resilience. Remember that. It's inefficient because of the 3 copies. Now think of this. If you have one Hadoop cluster running, and I've been working with multiple customers who have been in the situation, one Hadoop cluster running, whether it's running on cloud or running on-prem, and you want to have a disaster recovery for that, and you want to replicate that. Guess what's going to happen? If you replicate that to another Hadoop cluster, you're talking about 6 copies of data. That's even more inefficient. And the third one is the data keeps going onto the Hadoop cluster, it crunches it, and after it crunches it, you probably would not need to access that data ever again, but you can't delete that data. Now that data is sitting on Hadoop clusters, and it's not going anywhere. That's why it's called data lake. Question is, for that kind of data, would you really want to spend 3 times of more storage and have no resilience for that? So many customers are now looking for options where you bring the data into Hadoop cluster, crunch it, keep it there for X number of weeks, and then after that, you move that to a cheaper tier of storage. A cloud object storage is a great place to do that. So we will talk about these 3 use cases and how IBM can help you achieve and solve that. So let's see what happens when HDFS is replicated. So on the left-hand side, you have source data. This is your data center. Data comes into the Hadoop. Now again, it could be your data center. It could be you may be running on cloud, but you have your own Hadoop. Issue is 3 copies for all data and no DR. Why no DR? Because it's one cluster sitting in one location. If something bad happens to that location, you're going to lose all 3 copies. So customer do replication. You have 2 Hadoop, issue 6 copies. This is what we talked about in the previous slide. Okay. We can solve that problem with just simply 4 copies without changing anything in your Hadoop cluster. That's basically how IBM can help. And we have customers who have used the solution and are very happy with 33%, straight away 33% savings by having less amount of data. Okay, how do we do that? 2 solution components. Number 1 is IBM Big Replicate. Big Replicate is a software that IBM developed. It works with Hadoop and all distributions of Hadoop. It works with Hortonworks, it works with open source Hadoop, it works with Cloudera, and many others, MapR. It has a Big Replicate is a software that has a few functions. It can replicate, it can back up. Even though the name says replicate, Big Replicate, it can do a lot more than replication. It can do replicate, it can do archive, it can do backup. It can do all 3 functions. And it's a software that you can consume from the cloud or you can buy on-prem, whatever works for you. This Big Replicate software will, on one end, will talk to your Hadoop cluster, and on the other end, will talk to IBM Cloud Object Storage, which is where it will send the data to. So remember, we are talking about 2 solution components. Both are available on IBM Cloud. If you prefer to have Big Replicate software running on-prem, that's an option as well. IBM Cloud Object Storage would always remain on cloud. All right, use case 1. What is the use case 1? Which is replicate. So traditional deployment, when Hadoop is replicated to Hadoop, we talked about we have 6 copies of data. What are we suggesting? We're basically saying, if you have, okay, give me a minute. If you have Big Replicate, you can do Hadoop and replicate to an IBM Cloud Object Storage, which is on the cloud. So on IBM Cloud Object Storage, remember, it's not Hadoop. It's a simple storage. It can store 1 copy of the data. That means your Hadoop would have 3 copies. Big Replicate from IBM will replicate your Hadoop data to IBM Cloud Object Storage, which will have 1 copy. So 3 plus 4, 1, 4 copies. Now you are able to protect your Hadoop data by just having 4 copies, and you're leveraging cloud. You don't have to have your own data center for the replica copy. So that's one. Okay. Some benefits that it's a very straightforward use case, right? But the benefits are immense. First of all, when you do Hadoop to Hadoop, there is no guarantee on consistency of your data. Well, you have 6 copies and you would expect a lot more when your system has 6 copies. But remember, Hadoop is not designed for resilience yet. It really has a lot to catch up when it comes to resiliency in terms of consistency. So you will still have that as a gap, even though you have 6 copies. ICOS, on the other hand, it is designed for resilience. Johnny talked about customers who are using ICOS and store their compliance data. We have banks who are storing their compliance data on IBM Cloud Object Storage, which is huge. So it is designed for consistency. So even though you have 4 copies, less number of copies, you have a guarantee on consistency. Hadoop cluster maintenance can be expensive. Well, Hadoop is designed to leverage commercial off-the-shelf hardware. But remember, it's open source if you're invested with an open source software. And maintaining large Hadoop clusters can be quite complex and cumbersome. If you have 2 of them, it can even become bad. With Big Replicate and ICOS, you only have to manage 1 Hadoop, less number of copies. And when you invest with Hadoop, you gotta invest. Your decision to scale compute and storage is locked in. You can't have more compute without adding storage, and vice versa. In the second after scenario, at least for the replica copy, you don't have to have any compute at all. You're simply buying storage capacity on IBM Cloud Object Storage and have your Hadoop data in there. The other benefit with that is, if, for example, if your Hadoop is running on-prem and you're replicating your data on ICOS, if something bad happens to your Hadoop on-prem, you could spin up Hadoop cluster on IBM Cloud, and you don't have to migrate data because your data is already reached IBM Cloud. It's sitting on ICOS. And you can simply spin up new Hadoop clusters, new Hadoop nodes on IBM Cloud, and leverage the data that is already being replicated. So that's another benefit, side benefit that you get. Use case number 2, archive inactive data from Hadoop cluster, right? So we talked about how you can protect your data sitting on Hadoop cluster by replicating that from your Hadoop cluster to ICOS. Okay. Now we're talking about your Hadoop cluster is big. You are saying, well, the data that comes to Hadoop, it's not important that I protect it because it's not the gold copy, but my Hadoop cluster has become very big. There is a lot of data and huge amount of data hasn't been accessed, or it's old data. How do we handle that? Because now your Hadoop cluster will tend to become big. So it's an existing Hadoop environment. You have 3 copies of the data on the slide, as you see. IBM Big Replicate again comes into the picture. Remember, it has multiple functions. It can do replication, it can do backup, it can do archive. So we introduce IBM Big Replicate, which will work with your Hadoop. And we can set policy in IBM Big Replicate. We could have in this example, what we are saying is for the first 30 days, the data would sit on Hadoop. After 30 days, 30 to 60 days, it would sit on ICOS, which is on IBM Cloud. And again, we have multiple pricing tier, which I will introduce you in my next subsequent slides. So you keep your 30 to 60 days worth of data on ICOS, the little expensive tier, and after 60 days, you move that. It remains on ICOS, but a cheaper pricing tier, which is what we called cold vault. So you're paying a lot less. And remember, as long as the data is stored on ICOS, you only got to store 1 copy, not 3 copies. So that's another use case that you can have with your big data projects, and you can leverage ICOS along with IBM Big Replicate. I'll remind you, in case you have any questions, feel free to put your questions in the chat. because towards the end of it, we will pick questions from the chat and answer them as many as we can. All right, so this is a summary of what we just talked about. On the left-hand side, you have Hadoop. On the right-hand side, you have IBM Cloud Object Storage. Right in the middle is where IBM Big Replicate sits, and it has multiple functions. It has a function of replication, as the name suggests. It can do backup. It can do archive. So depending on what functionality you want IBM Big Replicate to perform, it will do that for you. And it does that for many distributions of Hadoop: open source, MapR, Cloudera, Hortonworks. All right. Now I come to the last section of my presentation, which is the pricing and how it compares against AWS. All right. And this is where we will have some poll questions. So I will really appreciate if you can give us your responses. So that's going to come in the next slide. We have 4 pricing tiers for ICOS. The first one is standard one, which is most expensive when it comes to storage, but data access is free, right? Remember, when you buy cloud object storage from anybody, you have to pay money to store your data, and then you have to pay money to access your data. And all the pricing tier is basically permutations and combination between these two. So standard is expensive to store, but literally free to access. You don't have to pay any money to access your data. That's standard, right? It depends on your workload. If you have a very active workload, which you expect to access very frequently, you go for a standard pricing. Then comes Vault. So Vault, again, we only have 2 dials. So a little cheaper to store as compared to standard, but now you got to pay money when you access that data. Again, it's designed for a certain types of workload. And then comes the cold vault, which is what Johnny was referring to, the cold backup, as the name suggests. Extremely cheap to store, but expensive when you access it. So remember, when we were talking about Hadoop archiving, if your data is more than 60 days old and you expect it to be never accessed, if at all it gets accessed, it will be very infrequent, you choose the cold vault pricing. So in the previous slide, we said 30 to 60, well, first 30 days, it remains on Hadoop. 30 to 60 days, it goes on Vault. And then after 60 days, it goes on cold vault. So that was basically the workflow in the previous slide example. So this is what you see from all the other providers. IBM has something unique. We call it flex pricing, and I will have more details on flex pricing in the next slide. Flex pricing, think of it like an insurance policy. So remember, when you have to pay money to access your data, imagine your invoice has no upper limit. If you access your data 100 times over in a month, you can actually get a huge invoice. Your monthly bill, usual monthly bill could be $1,000, $2,000, and suddenly you may get a $100,000 invoice because there is no upper limit when you access your data. And if your application can access that data 100, 200 times over, you can get a bill shock. Flex is a pricing tier which gives you an insurance that there will always be a cap on your invoice amount. It would never cross that. It's almost like a mobile bill where you say, if your monthly commitment is 5,000 rupees, if you spend less than 5,000 rupees, we're going to charge you the actual amount. But once you cross 5,000, your monthly bill would never cross 5,000. That's the commitment from IBM back to our customers. This is unique to IBM. No other provider has this flex pricing. So let's look at the real numbers. This is how much does it cost. Remember, there is a poll question. So it can be quite tricky, I can tell you, to calculate the overall cost when you are adopting a cloud object storage. Because you see right here, I can show you for standard vault, cold vault, and flex, there are 1, 2, 3, 4, 5 kinds of charges that you have to pay. And for a customer, for somebody who has not been in this area, it can be quite daunting. It could be quite inaccurate to estimate what would be the monthly invoice. So if you need help with a calculator on what would be your monthly estimated bill, Please, in the poll question, respond as yes if you need help. And someone from IBM will contact you, will share a calculator with you, and explain to you what would be your monthly estimated bill. But just quickly, we talked about 4 pricing tiers: standard, Vault, cold Vault, and Flex. You see, standard is about 2.6 cents a gigabyte a month, which is the most expensive storage. If you look at cold Vault, it's only 1.1 cents a gigabyte a month. So that's a storage price is dropping as we move from standard to cold Vault. But let's look at the second row, data retrieval charges. With standard, it's free, but it keeps going up as we move towards cold Vault. So that's what I was explaining in my earlier slide. Look at the Flex column. So Flex has a la carte price for storage, which is 1.4 cents a gigabyte a month, and then 2.9 cents a gigabyte for retrieval charges. Now, you pay that a la carte amount as long as you don't hit the cap, because in any month, for combine these two charges, we would not charge you more than 3.4 cents a gigabyte. That's the upper limit. Once you cross that, we will not charge you anything extra. That's what I was talking about. Flex is like an insurance policy where you know your worst case scenario. If you don't hit the worst case scenario, you pay for the actuals. So you basically pay the lower amount of 3.4 cents a gigabyte a month, or combined of your actuals. So you pay whichever is lower is what you end up paying. Again, unique to IBM. And if you're starting your cloud journey and you don't want to take risks, you may start with Flex because you won't have the invoice shock. So let's have a poll question now on if you need help in calculating your overall cost of storage. If you respond as yes, then you will have someone from IBM contact you. You'll have about a minute to respond to that question. I hope you can see the question. Again, the question is about if you need to estimate what would be your monthly bill, and that would depend on what is the amount of data. It would depend on how frequently you access the data. It depends on how small is your object size. It depends on a few factors, and it can be quite tricky for some customers. If you need help, please respond as yes. If no, then respond as no. Okay, so looks like the results have been published. And I'm not sure where you can see that. Okay, so apparently the results have been published. You could have a look, and we will get back to you with those of you who responded as yes. So let's move on. We have another poll question. We do have IBM Cloud Object Storage free 25 gigabyte available for you to try out for 1 year with any of your applications and any of those use cases. So in case you have interest in IBM contacting you and help you subscribe to this offer, again, there will be a poll question. Please respond as yes. And if you respond as yes, someone from IBM will contact you and help you get access to this 25 gigabyte free for 1 whole year. So again, I'll give you some time to respond to those questions. And if you respond as yes, please expect someone from IBM to contact you. So I think with that, while you respond to those questions, the webinar comes to an end. So just to summarize, Johnny talked about cloud object storage, variety of cloud object storage, a variety of storage types on cloud. He talked about the various use cases. Then I went deeper into the ranking of IBM Cloud Object Storage by Gartner and IDC, and talked about how you can use a combination of IBM Big Replicate, a software, and IBM Cloud Object Storage, which is on the cloud, to archive and to protect your data sitting on Hadoop file systems. So that's what we talked about. I'm not sure if we have enough time for questions, but I'll open that up. All right, so there's a question. It's called, okay, let me take that question. Is cold storage can be used as a backup tape safekeeping? So it's not designed to store your physical tapes. It's designed to replace your tape infrastructure. So instead of storing your data on tapes and sending that as an offsite copy, you can instead not use tape and store that on the cold storage. Cold storage simply is not physically a cold storage. It is a pricing tier. It is the cheapest storage available out there. So it's not a physical storage to store tape media. It is there. It's there basically to replace the data that you store on tapes. Doesn't public compliant repository risk security concerns regarding integrity of the solution? That's a good question. So question is about doesn't public compliant repository, I would say, I think it's compliant, not complaint, risk security concern. So I think IBM Cloud Object Storage that way is unique as compared to many other offerings out there. Just to highlight a few features that we have that none of the other providers have it out there. Number one is the worm capability. Write once, read many. You can create a bucket for yourself on IBM Cloud Object Storage and assign that bucket as a worm storage, write once, read many. And that simply means that once you store a copy in that bucket, you would never be able to modify that file. And that's typically a basic requirement for any compliance. We do have banks and financial services storing their compliance data on IBM Cloud Object Storage. So we do have precedents of customers doing that. The other feature we have is encryption. We have built-in encryption where you hold the license, you hold the encryption key, and we can stripe the data across multiple facilities, not just one couple of disks, but multiple data centers in such a way that your data would never ever be compromised, even if one data center gets compromised. So we could do that. Okay, I think this question, Johnny, you may want to take. How secure will it be to use serverless infra for an application to be used as a production instance and not just to use as a dev instance?
Sure. So serverless doesn't mean it is going to be running in a different context or outside of the realm of your containers or VMs. It is one of the evolving compute services. So the first generation of compute service was VMs. The second generation is containers, what we are currently experiencing. The third generation of compute would be delivered via serverless. If you believe VMs in cloud is secure, serverless is as secure as that, because the only difference is instead of managing the underlying infrastructure, you would focus more on your code and applications, and that's what serverless is all about. It doesn't mean you will lose control or it is less secure by any means when compared to the virtual machines or containers. So it is still running in the same security realm and the security context of remaining compute services like VMs and containers.
Thanks, Johnny. There's another question. What is the time frame to retrieve data from ICOS? So important thing to note about ICOS, all the data you store on IBM Cloud Object Storage is online. It's not sitting on some offline media, on some tapes, or on some optical disk where you have to wait for the data to get retrieved. It is all online. Whenever you need that, you start downloading your data right away. Amount of time it would take for you to download that data is going to be directly proportional to the amount of internet bandwidth that you have. So that probably answers your question. Can we change the replication in COS? I'm not sure if I understand that question. If you know who asked that question, if you could rewrite that, because replication is managed by Big Replicate, not in ICOS. So not sure what the question really is. What are the main advantages of COS which other companies don't have? Well, I was supposed to have a slide on that. Not sure how it got missed, but let me talk about the pricing first. ICOS compared to AWS is for a certain tier, it's about 47% more expensive. So AWS is 47% more expensive and has a lower SLA. ICOS in the whole market has one of the best SLA, which is 99.9% SLA across all the pricing tier. I think it's worth repeating. Let me say that again. We offer 99.9% uptime SLA across all pricing tier: standard, vault, cold, and flex. Our SLAs do not change with the pricing tier, which is an important differentiation against other competitors who have, with lower pricing, their SLA becomes lower. And in fact, for cold, for like Glacier, there is no SLA. So it is important to know when you are paying less, you are also compromising on the SLA. Not the case with IBM Cloud Object Storage. We have a common SLA across all the pricing tier. Only the pricing becomes lower or higher for two parameters, which is the storage cost and the access cost. So that's an important one. I talked about compliance, worm capability, write once, read many. Something I'm sure, the other players don't have. IBM already offers that. The third one is our ability to stripe your data across multiple data centers. So for example, we have a cross-region offering where you can write your data and we will stripe that across Asia Pacific, Europe, and US in such a way, and you're only paying for the one copy. You're not creating multiple copies. But we stripe that copy in such a way that we write that across multiple locations such that even if one continent is down, you can still access your data. And the amount of money that you save is just humongous. If in case you want to know more about that, please drop us an email and we would be happy to discuss with you how much can you pay with other players when you have to replicate data. For example, you store one copy in Mumbai. You are not happy that you only have, you don't have disaster recovery. So you say, well, I want to have a second copy. And then you pay for the replication from Mumbai, let's say, to Singapore. And then you pay for the second copy in Singapore. That could be a lot of money. We don't have a concept of replication within ICOS. We can simply stripe your data such that you're paying for the one copy of data. You're not paying for the replication and your data is still protected. So some of those features is what makes us unique. How will you ensure security in cold vault? Well, a couple of ways. Number one, it starts with our data center certifications. All our data center certification, we have multiple data center certifications which prove physical security of our data centers. That's one. Secondly, encryption. So encryption is built in, and when you send the data, your application can encrypt that data. Whether your application encrypts the data or not, we would encrypt your data. And then you have two options. You can have your decryption key, your private key, or you could store that private key along, the encryption key along with the data, which makes us unique. So that, there is no one single key which you're worried about that if that key gets compromised, your whole data would get compromised. We have customers who are even storing that encryption key along with the data so that it doesn't get compromised. So encryption is another one. another feature that we have. And then we have access control, where user can have predefined access to certain buckets, certain folders, and things like that. The other question is, do I need to take dedicated bandwidth for accessing storage, or can I cap the speed of access? Well, you don't have to have dedicated bandwidth. First of all, if you're subscribing to IBM Cloud Object Storage, it is simply accessible via internet. So as long as you have your internet connection, you will be able to access your data stored on IBM Cloud Object Storage. Now, if you want to have dedicated bandwidth, sure. Large customers do that to ensure that they do get promised output, promised throughput, I'm sorry. So if you want to go for a dedicated bandwidth, that is an option, but you don't have to. Where can we access Big Replicate? You could download that from IBM's website. I don't have the link ready right now, but if you drop us an email, we would be happy to get back to you with the link from where you could download Big Replicate. Do we need to contact Software for ICOS? That's the question. Yes, you could contact Software for ICOS. Or I know we've had multiple changes. We used to call it Software, then Bluemix, now IBM Cloud. But yes, Software, if you know someone in Software and you are in touch with them, do contact them. They would be able to help you with ICOS, absolutely. If we have 1 petabyte of data and we want to optimize bandwidth while storing data on ICOS, how do we do that?